So this picture shows you SAT competition winners from the original SAT competition 2000. The last one. So this is only the CNF application mental instances category. And so you can roughly divide the solvers into 3 categories: SAT based, written by Armin or derived from Armin, and others. So again, we have a small font problem. Yes, we need to live with it. So now we are going from chaff SAT. So we have already covered the conflict analysis and the BCP chaff. So what is left is its decision heuristic, conflict close deletion, and restart strategy. So this is the variable state independent decaying sum visits. Essentially, every literal has a counter initiated with 0. For every new clause, whenever, whether it is an initial clause or a learned clause, the counter for a literal in that clause is incremented. Again, it includes both initial and conflict. And the variable and polarity, the literal with the high score is always chosen. Ties are broken randomly, and periodically all the scores are halved, right? So this heuristic, so I'll talk about why this heuristic works well, but let me first give you an example of how it works. So this is kind of a meta example. So assume we have these literals in our formula and no conflicts till now. And so we go over the initial formula, which I don't show here, and count the appearances of the literals in that formula. So assume that this table shows you the score for every literal. So the number of appearances of every literal in the formula. And then what this algorithm does, it picks the literal with the high score. So node E appeared 6 times in the initial formula. It chooses it, then it runs BCP. Then out of all the unassigned literals, it picks the literal with the next, like with the high score out of all unassigned literals, which is not A in this case. And then it goes in this way, and assume there is a conflict now. So, and this is the conflict clause. What it does, it increments the scores for all the literals in the conflict clause. And then it continues the CDCL search. And once a certain threshold is reached on the number of conflicts, it halves the scores literals. That's how this works, at least in chaff's implementation. There will developers later. Now, why? So this heuristic was essentially a breakthrough. And why is that? Because in the heuristics before chaff, they went over all the clauses and computed some function f over every literal, every variable, and then chose that variable. But it's extremely inefficient because at every decision point, you need to go over all the formula. And also, it doesn't take into account latest complex. And this was a breakthrough because it has an extremely low overhead. So you have kind of a priority queue, which is very cheap and efficient. And you don't need to go over all the clauses at every decision point. And it's also conflict driven. So it's dynamic and local. So it takes into account the latest conflicts. And there is this part of halving the scores. So it's really oriented towards locality. So to learn information from the latest local context. So again, the SAT solvers are very good at that. Learning local information, like short, useful clauses to block from the search space. And so this is this. Other question?
Yeah. All right.
So now we go to conflict clause deletion. So it was noted like years ago that if you just keep learning clauses, not only in SAT, every constraint solver, if you keep learning clauses and you don't delete them, then you're in trouble. Too many clauses, too many information, too many catches. So you have to delete clauses, and what SAT did, It's just multiple combination once a certain number of peoples become unassigned. And finally, sets. This is also very important. So from time to time, some set formulas just unassign all the variables and then restart the process. Why is it good, especially in combination with instance of any other manipulating? Because like you learn, if you learn that certain variable is important, you want to start with the variable. So that's what the learning. Right? And if you get stuck, also if you get stuck, if the problem is satisfiable and you get stuck in a certain area where no solution, you want to also for both unsatisfiable and satisfiable business. And to change at least every same time. So to sum up, this is just the derivation of PVCM. So there is the slope, so it is science, instead of distance. Then the discipline is two are seen. Then there is functionality is perfectly and non-functional all this. And there are arithmetical instances every seven kind of complex and this whole division that we shared that mentioned. So this sounds just on. Okay, so now we go to the next solver, which is complex. So forklift, I mean, an industrial solver, so we don't actually know what's inside. So I am going to introduce forklift direct and simple development, which on also one categories of one of the first type competition is then after Dorte and means. Also, written by Goldberg on Dorte and one means. All right, anyhow, closed relation strategy in Dorte, it was based on age and size. So again, the idea here is that you don't want to get exposed. You want to get exposed in which you can touch. In this, you can touch more to that one you live. And so that makes sense. Again, you want to focus on the relevant local information, and also you want to keep short codes so it makes sense again. And what clauses and the magical constant for restarting was changed from something. And there was also the innovation in the figures, which is quite useful. The idea was to use this was not only on the results in the content code, but also on the visited results in the application graph. So let me give you an example. Shaft in this situation, right? Here. Content code, which is you can just remove initial code unless you have to put them by stronger. You shouldn't have to done that. All right. So yeah, this is the most how broken move this course. So in this situation, so we have here the application graph, we have the path, right? And this is the conflict close. So shaft increases force of the literals in the conflict close volume, which is not in of C or not D, whereas drop will additionally to the literals also move the score of all the visited literals on the conflict side of the graph. No, apparently empirically, these literals are also important. So if you pick them, you can kind of check for this info. So that's what they did, and it actually stay like this. Now, another thing which Broken did is close based heuristics. So I have a slide on that. So in Broken, it used clauses to decide which variable to choose next. What they did is so they had a stack of conflict clauses, and the next variable was picked from the top most unsatisfied clause. If all the top conflicts are satisfied, then just do this. Back to business. But then there is like a hitter of the heuristics. There was also clause heuristic in the Haifa subsolver, which was an ordinance in one of the sub conditions. The idea there was to move clauses within your compliance to the top, which are similar to the idea of getting the scores from these literals on the side of the application graph. Then so we had a paper about
CPH conflicts closed-based heuristic in which all the clauses are equally set or only the initial ones. And then you just choose the literal from the highest or most unsatisfied clause. Now, the end value of the heuristic is that they tend to take interrelated variables. If you assign together, they take the whole. So this heuristic didn't make it eliminate the modus solvers, although I'm still using CPH important. Sometimes it's very useful, especially if you put it to the initial clause, they just satisfy them, and the clause is satisfiable. And there was a recent paper about CBH, that if you modify it, it works on frame-based production control. So I still think there's potential to use it. Yeah, but again, like I said, they didn't make it over. So far. Now I'm going to talk about Minisat and satellite GPI. We have no questions. So Minisat is a very well-known solver for the test of time of words. It started 2 years ago. A simple name engineering from there is a worldwide solver that they assume based on Minisat. Additionally, it has some useful heuristic techniques like exponential limit to go over and on optimization. And one very, very useful feature with API, is an API, which enables incremental fast fundamental fast. And it's an enabler of major major real-world flows. Then there's also a satellite preprocessor, which is also breakthrough, and it's one to solve very complicated pieces in real life. So let's talk about this heuristic now. So there are several innovations. First, there was this idea of separating variable and polarity heuristic. So the initial problems, the score was associated with literals, and in Minisat, the score was associated with variables. Then you can like separate variables in heuristic and polarity selection, and it's actually very handy because then you can develop something called polarity selection for the following. And it also moved like maybe a bit more dynamic. There is an exponential factor now in when you increase the scores, and you increase the scores after every conflict by this exponential factor, and then you need to rescale at some point. This is even more dynamic than the original pieces. And most features updated with the and now Minisat used geometric series for instance, which is kind of too small to make a problem solvers. And for closed division, instead of using like H, like in Broken, there is a float number associated with every close, so there is not this number in the float buffer. And so you update it whenever the float participates in the content derivation. It's how it works even now, and periodically the left after float. So now the activity is like inside the process. It's going. Now I'm going to talk about satellite processing, then about conflict-mode minimization. But before that, I want to present you the notion of resolution of that. Because these techniques affect resolution. And also variable elimination. So, resolution. If you have two clauses of the form C or L and G or not L, where C and G can be deducted from the one now, you can derive the clause C or D. Okay. Now, why is it correct? Because assume we have an assignment satisfying the first clause, then L should be either 1 or 0 clause that assignment. If L is false, then C must be satisfied, and so the derived clause is satisfied, and if C is true, then D must be satisfied, and so the derived clause is satisfied again. So this resolution is correct. And this is just an instantiation of resolution on L. So you can A or B or L, C or B or not L, and you just get A. In the argument clause, you can add it to your formula and of time, correct? Now, we also eliminate variable by resolution. So assume you want to eliminate variables, I mean removing all the clauses which contain a variable and replace them by other clauses. So still we have variable L appearing in all these clauses, right? And we want to eliminate it. In order to do that, we just create all the possible resolvents between the clauses where L and not L appear. So here L appears in clauses CI, where the first the header is C, and not L appears in clauses where the header is D. And so we just have all the possible resolvents between C and D, CI and D. And this is satisfiable. Again, why is that? So first, let's assume that there is a solution and a sign which satisfies the first part of the formula. So and let's assume that L is 0 without the generality. So if L is 0, then all the C's must be satisfied on the left hand side, and thus all the codes on the right hand side are also satisfied because they contain C. Every code contains some C value, right? Now, for the second part, second direction, if there is an assignment which satisfies the right hand side, the derived clauses, then it also must satisfy the left hand side. Now, why is that? So assume we have, so first of all, if our assignment satisfies everything with CI and DJ, then we are done. But there is CI and DJ in every clause on the left. Now assume it doesn't satisfy, for example, C1. If our assignment, which again, the right hand side is satisfied, if our assignment does not satisfy C1, for example, then we choose L to be true, right? On the left hand side. And then if C1 is not satisfied on the right hand side, then every D must be satisfied. Because we have to close for C1 or D1, C1 or D2, C1 or DI for every I. And thus all the D's on the left side are satisfied. Right? All the clauses of the form TI or whatever are satisfied because TI is satisfied for every D. And every clause from C, J, or L is satisfied because L chose L to. That was just a proof that final addition is correct. So, now this is again it's a demonstration of variable elimination on real code. So we eliminate them. It's all the clauses, and there is only one tautology. So if there is tautology, you don't need to write it down. You don't need to keep it. So here, if there is no like those, or this clause or clause, with the third one, you get A, B, or C, and the clause. And then if there is no the first one, in the fourth one, you get a tautology because B appears positive here and negative here. So the result of both tautology, so we don't need all this, and then we just will this. All right.
That's like it looks like it's really bad in terms of space complexity if you want to eliminate it. But yeah, I guess in practice.
In practice, it's done like this, probably the next slide. It's done bounded by elimination. So you do it only if you don't think the formula after the closing point. So not I mean, if it works like smoothly for every variable, then it will be. I think we have a question.
So, in Armies, category the hidden inside category which tries to check something. Well, yeah, yes, so okay. Are you talking about the definition of things?
I don't know what it's.
Oh,
Nice good. Okay. We can still have a question after about it. Okay, so let me just present some function and some definition. So some function If you have two clauses with the form C and C or D, you can just remove the previous C or D. C will be both of them. And this is just again instantiation, and then if you have self-fulfillment and then self-fulfillment resolution, if you have two clauses of the form C or D, then C and D can be set to results or L is a single literal, and then C or not L, you can resolve these two clauses, and then you get the clause C or D without the L, so you can remove it. This is self-fulfillment. Now, again, this is translation. Okay. Now we can talk about the satellite report, the original report that from 2005. So it is running the following system. First, bounded variable elimination. So variable elimination, but only if the number of clauses doesn't go at all, or grows by some counterpart. So we should go for the variables, and if you can eliminate and say you have not more like if you have n clauses, then you can increase it by around 25 10 plus 2 without or not, there's the next number of critical clauses. And then there is beta limitation, which I will talk about next time. And there's subsumption and self-supplementary resolution. That's something. This is actually a very powerful thing, especially when we go ownership. Yeah, so to call it on many instances. Let's talk about gate identification. So the idea is the reduced number of generated results when we eliminate the code. But it's actually stronger than that. Because when you check whether you can eliminate the variable, if you use this data identification, you can eliminate more variables. So this is very good. I will show you how it works with an gate example, but it's applicable to other gates too. So here we have an example of how a gate, an AND gate is encoded to local. So we have an AND gate here. So, right, G is equal to A and B. If you translate a circle, if the original problem is a circle, you want to translate it into start with this then you generate clause for, in this case, AND gate. So we have the first clause says that essentially if G is 0, then one of A or B must be 0. First clause. And the next clause says, the next two clauses say that if G is 1, then A and B must be 1. So this is the way to translate the mandate clauses. So this technique, creating this identification doesn't follow. When it considers an eliminated variable, G, it checks whether G was created by translation, in this case, the AND approach. Other means two clauses. Essentially, it checks whether this clause or a significant variant are there. So by significant variant, I mean, for example, that if B, for example, here, was eliminated by self-fulfillment resolution, then you will still amend it. Originally was amended, and algorithms are in general capable of identifying these cases. Now, if there are no such clauses, then this optimization is not applicable. If the clauses are there, so we can resolve on less clauses. So the clauses false. We divide the clauses into essentially two categories. Clause G clauses, which represent the gate, and the rest of the clauses which contain our variable G, denoted by R. And then there are G plus, G minus, R plus, and R minus clauses, where the plus clause contain G, and the minus clause contain non-G. And there are four categories now called G plus, G minus, R plus, and R minus. And the thing is that you can create only results between G and R. They don't, so result between the G clauses use only tautologies. So we can check that result. So there are two resolutions here, and there's a tautology that we resolve. And now, and the resolution between R plus and R minus is essentially unnecessary. So the clauses are redundant because they can be derived from the other clauses. Let me show you why. Yeah, the results are obsolete. So here we have an example clause P or G which goes to R plus, so G is there, and N or non-G which goes to R minus, non-G is there. And supposedly the result will be pure F, but we don't need it because we can derive it from clauses of G and R. And why is that? So here we have the representation of again, for the mathematical response of all these this line should have a system itself. So, but anyhow, what we do, there is no care between R, like the two clauses R plus N not G of A, and we get P for A, so we get rid of G. And here we have P or A, and then we have N or not A or not B, and we can just resolve these three clauses to get P or N. So this is supposed to be pure N. Exactly the clause which we would have got from resolving between R plus and R minus clause. You can always derive this clause from R. And again, as I said, it's very useful. So I think if you have a question for Javier after this.
I mean, what there was saying is that in the detection of these, there is another SAT solvent that's used. I understand correctly.
Yes, you can actually do some not syntactic gate extraction but semantics to try to find the function. And like in his side, this is used with separate sets over. But it existed in reading before that the set can also do sort of proofs. And you can be a electron papers. Electron papers for mining the emissions.
Yeah, so instead of going to semantic, we can use semantic to identify something similar to the definition. So, all right. So now we are getting to non-closed minimization. This is the last technique for me, which I will put it. So the idea is during conflict analysis, after we derive the conflict clause, you can further minimize it by resolution with the parent clause or the literals in that clause. So there are two options, so two flavors: local minimization, which is bigger, and default minimization, which is stronger. And now this is standard. So in local minimization works as follows. So given a new clause C, whose assistance in the integration graph, you can try to remove literals by resolving for every literal solved with the parent clause. Let me just show you an example. So we have a formula here. We have the integration graph, right? And so we have this topic. I copied then the associated integration graph. And notice here that we have the literals not B and not C in the whole clause, right? But C is implied by B, right here. So you can just resolve the parent clause of C with the new literal counter clause, and you get shorter clause, which substitutes the original. So we don't need the original counter clause, but this new one, right? So, get it clear? So you have a conflict clause, and then you go over the literals in a conflict clause, and you try to essentially resolve the clause with a clause where each literal was implied. And sometimes you may get shorter clause in terms of doing the function. So that's the idea. You just remove those clauses previously. But there is a shortcut in this technique. Let's consider this formula and this conflict. So here, if you try to resolve this clause with the antecedents to the parent clause for C, you get D, not B, inside the clause, and so you cannot substitute the original clause with the new clause. But if you continue the process, you would eliminate B2, right? Because A, not like in the first clause, A by B, we can eliminate it. So in recursive minimization, that's exactly what we try to do. You try to eliminate the shit recursively until you get a deep decision maker which can cannot eliminate it, or you successfully get the code which substitutes the original code. So in this case, process will be continuous, and this code which substitutes the original code will be derived. And that's what the reason does, and I will solve it. Question? So again, there is a resolution for but I call it inside solution. Ultimate. Okay. Remove this post. So this is the summary of how music works in non-incremental mode. There is pre-processing, so it has variable elimination, there's gate identification, a substantial and self-fulfilling resolution. The variables is unique EV6, which is an exponential version of music with polarity 0. There is a minimized total field scheme for ordinary smooth. It treats us with geometry series and a conflict close deletion function in a field. This is mini-static. Okay. Now, transition to the second part of my presentation, which is applied standard example. So, I'm going to provide several examples and show you how you can, how such one can be used. So here we have an example of this sort. This is a counter, to the counter with an enabler. So essentially, it starts to count. So it has two memory elements, two lashes, and the original value, the initial value of the lashes is posed to them. And then what it does is essentially, so we will think of ontological lashes as a number, right? A binary number. So from this number, the first cycle number is 0. And the number changes whenever the enabler is 1, the enabler is essentially models the flow. So if it's 1 in the first cycle, then it's 0 the next one, etc. And the counter moves, is increased whenever the enabler is 1. So it starts from 0, and then it is increased to 1, because the enabler is 1 in cycle 0. Then it stays the same because the enabler is 0 in the next cycle. Then it's increased to 2. Stays the same and increase the 3 times. Here's like a textual presentation. So, and the sort show start from. Now, in hardware model checking, the caller has to answer the following question. Given a struggle and a property, does the property always false? And one of the most popular categories of properties is safety property. Essentially, it's something bad will never happen. You want to check, like for example, for the relation hardware, you want to check some properties of your software defined by the engineer. So here's an example property. The counter never reaches the value of 3. So as a fault, no, not fault because X cycle 5 is faulty. So how can we solve this kind of logical problem by the actual SAT? So there is this multi-model checking procedure, which is very popular and it's often still widely used by industrial and hardware validation tools, because it can handle very large and complex cycles. Unlike complete model checking techniques, which are also very useful for smaller software cycles. So what it does, it unrolls the software, it goes over the bounds until bound N, which is provided by the user, and checks whether the property falls in a software which is unrolled to the bound. So again, it takes the software and unrolls the base several copies for every bound, and then it sends the query whether formula unrolled bound D. And the negation of the property satisfies the solver. If it's SAT, then there is a model. And the model comprises the button, right? It's a test button. If it's unsat, then there is no button until the power. So let me show you an example. So this is a very simple circuit. And our property is H implies B. For this circuit, it always holds, it doesn't depend on the latch. For if H is 1, we have 2 elements here, B must be 1. Right? So the property holds. But let me show you how it is translated to SAT. So for like using this homology in this case, in cycle 0, we just cut off the output of the latch. And instead we put, like we create one copy of the circuit, cut off the output of the latch, and then we assume there is a user given initial rate on the latch, and we translate the circuit to SAT by translating every gate to SAT. These are AND gates that we've already seen how they are translated to SAT. And then we translate the negation of the property to SAT2. So in this case, the negation comprises period clauses on B and H. Right? The negation of H and Y. And we say it with SAT2. Now, this is unsatisfied. Property is unsatisfied. So what is carried out next is unrolling to the next step. So we create another original circuit and provide the output of the latch to the next copy of H. So provide output of C to the next copy of H. So this is unrolling. After unrolling, we just create clauses. And so for the points, we create clauses for every gate and the negation of the property, which is now so we instantiate for the cycle 1. So the property says now that next of H, like next of B, and this is uncyclic. How it goes like this? This is the B supposed to. And now I'm going to talk a bit about incremental subsum. So how can you reuse the information from the previous source? So the analysis can be very useful. In this case, one can see that there are clauses which hold globally, right? All the translation of the gates to clauses we hold globally for every possible unrolling, right? Every possible location of the subsum. But the negation of the property, they hold temporarily only for their own type, right? So you want to be able to somehow read the information from the rest of the globally from the clauses which hold globally in the next cycles. So one way of doing that, called pervasive clause learning, was related already by Otis and Grasp. So you have a sub instance, and then whenever, so they create a separate sentence for every cycle, but whenever a clause is learned only from the global clauses, you can flip it to the next global instance. And you can like follow the clause by just marking the one bit. But you mark every clause with a bit, and then if the clause depends only on the global information, you just propagate, you provide the next copy of the cycle for the next one. But a more useful technique than now by the state technique was writing the instance, which is subfolded under assumptions. In subfolded under assumptions, you do not provide a temporary clause to the instance at all, but rather you provide them as an assumption, which means that the first definition difference. So in the initial integration to SAT, you provide the solver only the global clauses, and those clauses you don't provide these clauses at all, but as assumption, which is to say the first decision difference. So you just start the exploration process with the node B followed by BCP and then H followed by BCP. And in this thing, every clause learned, if it depends on the assumption, it will just have the assumption inside. The assumption, it depends on inside. So this is actually a very elegant technique. And so you can reuse the same technique. You don't need to delete it, you don't need to destroy it, because all the information, all the clauses are global. All the clauses are pervasive in the grasp. So here is the API of the incremental subform with under assumption. So the basic API goes as follows: to edit clause, and then you can solve it under the assumption provided by you provide the solution. So that's quite simple, a very simple API. And the solver returns SAT, comes back with SAT. If the conjunction of all the clauses provided to part and the current assumption is satisfiable, Otherwise, we have that with an answer. Result. Now, you can use the API to add those flows temporarily. Just mark every group you want with a new selector or activation variable S, you get every flow you want to add. And then you can solve under, you can add not S to the assignment. And this way, you can provide temporary flows to your solver. Temporary flows, which is very useful for many, many applications. And in order to delete the temporary flows, you can just do nothing. The solver will be deleted at some point, or add unique flows as to the different flows stream, which is more efficient. So, question? This is the basic API of SAT API. So as I said, it's a graceful, it's extremely easy to use. And since it retains all the information of the codes and all the responses across all the grids.
No, I just wanted to mention that in this schedule, there is another 15-minute coffee break around this time. But I'm not sure if anybody wants for the coffee break.
Okay. No. So the standard answer,
Yeah, so
and it's enough hour and
it said there's another short break in between, but if everything is okay, then we can just something else.
so how much time do you
You have to, but 45. There was a break around this time. If you want to use, we can take 5 minutes break. Or maybe we just wait for 5 minutes. Yeah.
Hey, there's a small note. So, points that I use, it's like the heat has a Wi-Fi details. And there'll always be the bits just outside the sound. And there should be no photography around this campus and no food and no videos inside the zone. And also remember that towards the end of this day, you have to return the ID cards just outside, something like I just. Yes, the other distance ID cards. Black one. If you submit it, you can take it again tomorrow morning.
I have a short question. I think
Yeah.
in staff, you said that if we start having 700 conflicts on something, and it also regularly release a lot of people. Is it in the conflicts?
So you need to, you need to make sure that there is one new clause after every reset to make it complete. Yeah, but I don't think that in practice, like some of developers care about it because like what might really matter is what in practice. So I don't think there is like a guarantee actually that these ones are very good. I'm not sure.
Yes, also the like US side of fast.
Extended. That's right. Yeah, it should.
Okay, thank you.
Like if you backtrack chronologically all the time and have no restarts, then it will be complete. Because then you just will go over it.
Without restarts or without deletion.
Yeah, without restarts is complete, without deletion is also complete. Yeah, but yeah, you're right.
With both, it's not clear.
It's, yeah, you need to make sure there is one new clause between every
Yes,
restart.
okay.